So the way this class, Math 140, is broken down is we're going to spend the first 2 or 3 weeks talking about simplifying and evaluating expressions. So we really want to make sure you understand the difference between an expression and a equation. And in one sense, the word here helps us. Equation hopefully makes you think of an equal sign. So an expression, what's the difference between an expression and an equation? An equation has an equal sign. So if you have, for example, 3x plus 2, that's an expression. If we have 3x plus 2 and someone tells us that it's equal to 5, we could say equals 5 here, and now we have an equation. This is an expression, that's an equation. Okay, so it's impossible to solve an expression. We can simplify an expression. We can evaluate an expression. So under expressions, we can simplify them. Simplify. We can evaluate. But we cannot solve. We can only solve equations. I mean, we can solve problems. We can solve other things. But I mean, in these two possibilities, an expression we can simplify and evaluate, and we can solve an equation. Okay. Now, evaluate, usually if it's a variable, if it's an expression containing a variable, we need to know the value of the variable in order to evaluate. Now, if it's just simplifying, we don't have to know the value of the variable. Like, for example, this one's actually, it's in simplest form. But if we had, for example, 3x plus 4x minus 5, that would not be in simplest form. So we could simplify that expression. We could write it as 7x minus 5. Because 3x plus 4x equals 7x, okay? And we can do some simplifying on either side of an equation. So in other words, if I had 3x plus 4x plus 2 equals 5, we could simplify this side of the expression by adding 3x and 4x together, and we get that, okay? So basically an equation is made up of setting two expressions equal to each other. So this is an important distinction. So the first 2 or 3 weeks, we're going to be talking about dealing mainly with expressions. Simplifying them, and evaluating them, among some other things. And then the next couple weeks after that, we'll talk about equations and solving them for the most part, but also writing them and some things like that. So in the process of simplifying expressions, sorry about that word, we have to have a lot of skills. So if you think about PEMDAS, please excuse my dear Aunt Sally, or parentheses, which really stands for grouping symbols, exponents, multiplication, division, and addition, subtraction. There's a lot of operations that might go into simplifying, and that's not even all of them. There's more. So in order to be good at simplifying expressions take a lot of different forms. So we have to develop some simplifying skills, and that's what we're going to be working on for the next 2 or 3 weeks. Okay. So this video is about handling exponents correctly. Okay. So for example, first we'll just start out what exponent means. When you see 2 to the third power, hopefully at this point in your mathematical career, you know that means it's just a quick way to write multiplication. That's why they call exponents repeated multiplication. So in other words, I could write this as 2 times 2 times 2, but it's more convenient to write it as 2 to the third power. Now we would call this the exponential form, and we'd call this the expanded form. Just a little vocabulary there. Expanded form, exponential form. Okay. So the important thing is to understand what an exponent means. When I see, same thing is true when I see an x cubed, that also means x times x times x. Right? Exponential form, expanded form. Okay? Now, again, at this point in your career, you probably already knew that. So, but what you might have a little bit more trouble with is when we have exponents playing together. For example, when you see x squared times x cubed, you should be able to simplify that, because there is a simpler way to write that. X squared times x to the third can be written as x to the fifth. Well, how do we know that? Well, some of you may have somewhere learned and memorized some exponential rules. For example, like when you are multiplying two powers with the same base, you add the exponents. Okay, that's one rule. There's another exponential rule that says when you are dividing two powers with the same base, you subtract. Whoops, a daisy. Sorry about that, guys. I just flipped to a different page. You subtract exponents. Okay, and there's a third rule that says when you raise a power to a power, you multiply the exponents. So these are just shortcut rules in a sense. So when I look at this, I'm multiplying a power by a power, and they have the same base. Notice that same base is really key in both of these. So I'm multiplying a power by a power, and they have the same base, so therefore I can just add their exponents. Now, as I said in my last video, I'm not one for memorizing. I don't like to memorize things. I'm not very good at it. And if you had to memorize everything you're supposed to know in math, you would, well, you'd have to have a very large brain. So rather than memorizing something, I would rather you understand it, because if you understand it, it's a different mental action, okay? So when you look at this, we know that x squared means x times x, and we know that x cubed means x times x times x. And you can see the reason why you end up adding exponents here is because all the exponents are doing are counting how many times I've multiplied by x. So in a sense, you're saying I have 2 factors of x here, 3 factors of x here, so I have a total of 5 factors of x. That's why it's x to the fifth. Now, I'm not suggesting that every time you do this, you have to write it in expanded form and count the x's and then write it, but I think seeing me do this in expanded form helps you to understand that why that rule works. It's not just a magic trick that anytime you have things with exponents on it, you add them. Because notice the important thing here is when you're multiplying 2 powers with same bases. So if you had x squared times y cubed, there's nothing you could do there. It would just be x squared times y cubed, because they don't have the same bases. Or if you think about it from an understanding perspective, this is just x times y times y times y. And of course, there is no other simpler way to write that than just x squared times y cubed. You can't simplify it any further. So likewise with the second rule, dividing by 2 powers, or dividing 2 powers with the same base, we end up subtracting, because if you have, for example, x to the third on top and x to the fifth on the bottom, notice that's the same thing as x times x times x over x times x times x times x times x. So, and we know that if you have a divide an x by an x, it's the same thing as 1. So I can cancel that out and cancel that out and cancel that out. So that leaves me with 1 over x squared. So the rule says that if you divide 2 powers with same bases, you can just subtract the exponents. So that would mean that this is going to be 3 minus 5, which is x to the negative 2. Are those the same thing? Well, yes, if we understand negative exponents, remember a negative exponent just means you need to put it on the bottom if it's on the top, or put it on the top if it's on the bottom. Or another way to think of negative exponents is they give us the reciprocal. So x to the negative 2 is is equal to the reciprocal of x squared. The reciprocal just means put it over 1, or put it under 1. Okay? And then the last one is the hardest one to remember. Raise a power to a power, then you multiply the exponent. So that would be like if you had x cubed raised to the 5th power or something like that. So this really means x, I don't want that many, let's just go squared. That really just means x cubed times x cubed. Whoops, I said x cubed. My pen's not listening. And again, if we wanted to expand that further, that really means x times x times x, because that's what x cubed is, times x times x times x. And so we can see that that ends up being x to the 6th, which is just 2 times 3. Okay, so those are the 3 rules that you probably learned somewhere, and I just want to make sure that you understand them and know how to apply them. But don't rely on them in just a kind of a blind memorization. You want to make sure you understand them. Because what will happen is we'll get these more complicated problems, like, for example, x squared raised to the 3rd power times 2x to the 4th raised to the 2nd power. And you're asked to simplify that, okay? So if I have to simplify that, that means I'm going to write this in its simplest form, and which means I'm going to have to conduct some operations. So, for example, I'm raising a power to a power here, and I'm raising a power to a power here. So again, the rule says if you raise a power to a power, you just multiply the exponents. So that first one's pretty easy. That's just going to be x to the 5th. Sorry, I guess it wasn't that easy. X to the 6th, because 2 times 3 is 6. Okay? Or we could think of it as x squared times x squared times x squared, which is also x to the 6th. Now, the second one is a little bit more complicated because I don't have just a power raised to a power. I have a number times a power raised to a power. See the difference? So really, this is just 2 x to the 4th times 2 x to the 4th, because that's what squared means, right? So you can see if I write it out like that, it becomes hopefully clear that this is really x to the 6th times 2 times x to the 4th times 2 times x to the 4th. So we have a bunch of things multiplied together here. And if you understand multiplication to be, if you remember, multiplication has a commutative property, which means you can multiply it in any order you want. In other words, 2 times 3 is the same thing as 3 times 2, right? Doesn't matter what order you multiply it in. So I could, because I want to multiply the 2 by 2, I'm going to do that first. So 2 times 2, of course, is 4. And then I have all these x's left, x to the 6th times x to the 4th times x to the 4th. And now I can multiply all of them. So that would be 4 times. Now again, this is keeping track of, I have 6 factors of x here, 4 factors of x there, and 4 factors of x there. That's a grand total of 14 factors of x. So this would be x to the 14th power. Now, if you need to write them all out, go for it. You can make a little, this is the same thing as 4 times 1, 2, 3, 4, 5, 6 times 1, 2, 3, 4 times 1, 2, 3, 4, and then just count them up. There's going to be 14 of them there. Again, I don't recommend you do this because that gets old and takes a long time and it's slow. But initially, if that's what you need to do, then do it. You just got to make sure you're getting these things right. And again, not blindly following a rule and just randomly adding powers together because it seems like it might be the right thing to do. Make sure you're understanding why you're adding exponents if you're going to do that. Okay. Let's see. What else do I want to say about this? Of course, this can get hairier because if I have, for example, 3x squared times 2x to the 3rd squared over 4x to the 3rd. Okay, so, each step we're getting a little bit more hairy here. So once again, you kind of want to take it slow and make sure you do things carefully. We can just follow the rules if you can handle that. But keep in mind here, this is, you're not going to, this is 2 squared and that's x cubed squared, right? Or another way to think of it is, right away you could say this is 3x squared times 2x cubed times 2x cubed. So I'm just applying what the squared means. Factor this out, and this is 4x times 4x times 4x. Okay? So then my next move maybe would be to get all the numbers together and all the x's together. So I can see on top that it's going to be 3 times 2 times 2. Well, 3 times 2 is 6. 2 times 6 is 12. So that's a 12 out front. And how many factors of x do I have there? Looks like 2, 3, 4, 5, 6, 7, 8. So that'd be x to the 8th. And down at the bottom, I have 4 times 4 times 4, which is 64. And then x times x times x, which is x cubed. And then, of course, I notice I have things on top that will possibly cancel here. So, for example, 4 will go into 12 3 times, and 4 will go into 64 16 times. And here we have 3 of these. We'll cancel out 3 of those, leaving just x to the 5th on top. So I have 3x to the 5th over 16. Or if you wish, you could write this as 3/16 times x to the 5th. Doesn't matter to me. Both of those are wonderfully good ways to write that. So again, if we're talking about simplifying, these are equally simple. Doesn't matter which way you write it. Okay? Now, yet another application of, if you understand, once you understand exponents and can handle them pretty well, one way we use exponents a lot is in scientific notation. So for example, if I have a large number like 32 with a whole bunch of zeros after it, so like if we're measuring the distance to a star or something like that, or the size of the sun, or I don't know, diameter of the sun, there's a lot of things that we do in science where we measure large numbers. It gets tedious to keep writing all these zeros. So what we can do is we can take 3.2, and we always write it as a number between 0 and 10. And often we need to use a decimal to do that. And then we say, but it's not actually 3.2. It's 3.2 times a whole bunch of factors of 10, isn't it? So in order to turn this into that number, I'd have to multiply. So here's my decimal. I have to multiply, whoops. Because remember, when you multiply by 10, it just moves the decimal over one place. I'd have to multiply by 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So we'd write this as 3.2 times 10 to the 11th power. Okay, so that's scientific notation. And likewise, we use it for small numbers. If I had 0.000000438, okay? So this might be if you're measuring the size of a small particle or something, the diameter of a small particle, or the space between electrons and neutrons. You can have very, very small numbers. So again, instead of having all these zeros to contend with, we could write this as 4.38. And again, so we're taking the decimal from here to get it where it should belong. That would be 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we're dividing by 10 8 times. But because we understand exponentials, we can write that as 10 to the negative 8. Because remember, a negative exponent means reciprocal. So this would be multiplying by 1 over 10 8 times. Okay, so that's scientific notation. Now the cool thing is, if for some reason I'm multiplying, I don't know of a case where I'd multiply these two together, but if I'm multiplying 3.2 times 10 to the 11th by 4.38 times 10 to the negative 8, I don't have to expand them out and multiply them like that. I can just, because this is really the same thing as 3.2 times 10 to the 11th times 4.38 times 10 to the negative 8th. Whoops, why did I put an X there? Come on, Dad. So notice these, because again, this is multiplication, the commutative property, we can multiply in any order we want. These two I can multiply quite easily, and I can get 10 to the, so this would be 11 minus 8, that'd be 3, wouldn't it? 10 to the third power. And then I could just multiply 33.2 times 4.38. So that would be 4.38 times 3.2, 16. 2 times 3 is 6, 7. 2 times 4 is 8. 3 times 8 is 16. No, it isn't. That's funny. 3 times 8 is 24. 3 times 3 is 9, 10, 11. And 3 times 4 is 12, 13. 6, 11, 10, 4, and 1. And there's 3 decimal places behind the numbers, so I go 1, 2, 3. So this would be 14.016 times 10 to the third. But notice that my number out here is not between 0 and 1, so this is not proper scientific notation. So I'd have to change it to 1.4016, and of course that would change my factor of 10, wouldn't it? So in other words, to make this, to get this back to that, I'd have to multiply by an extra 10. So that would make this 10 to the fourth now. Okay, so that's a quick rundown of scientific notation. There'll be a couple questions about scientific notation in your homework, but a lot of your homework will be dealing with just playing around with these different types of numbers involving exponents. For example, one more example here, like x cubed y squared to the 5th over 3x squared y to the negative 3 raised to the 2nd power. So again, we could multiply this out by itself 5 times, or you could just think that in your mind and think, okay, this is x cubed y squared to the 5th 5 times, multiply together 5 times. So that's really x to the 15th and y to the 10th. Okay? Because you can picture 5 of those multiplied together. Y squared times y squared times y squared times y squared times y squared. Okay, same thing's down here. This is going to be 3 squared, which is 9. That's going to be x squared squared, which would be x to the 4th. And that's going to be y to the negative 3 squared, which would be y to the negative 6. Okay? Now, that negative exponent is maybe going to bug us a little bit, so we can get rid of it by just moving it to the right place in the fraction. So I put y to the 10th here. That becomes y to the 6th up top. And then I take away the negative because it's not in the wrong place anymore. Then I have a 9 and an x to the 4th. So again, that's the way I think of negative exponents. It means the reciprocal, but another way to think of that is it's in the wrong place in the fraction. If it's on the bottom and has a negative exponent, you can move it to the top and get rid of the negative exponent. Or if it's in the top and has a negative exponent, you can move it to the bottom and get rid of the negative exponent. Okay, so now we can just kind of clean things up here a little bit. So we're simplifying still. So x to the 15th divided by x to the 4th would be x to the 11th on top. And y to the 10th times y to the 6th would be y to the 16th. And then on the bottom, I still have a 9 there. All right, so I think I'll end this video here. So this is really a rundown of handling exponentials properly, and just a revisiting of the exponential rules and making sure that you understand where those rules came from. Oh, one more thing just for vocabulary. When we talk about exponents, we talk about the base and the exponent. I just remembered I didn't say this. So like, for example, x to the 3rd, that is the base and that is the exponent. Or even 3 to the 5th, base, exponent. And oh, and one more thing, I'm sorry, while I'm thinking of this, those rules apply to whether it's numbers or variables, right? Because the rule says if you're multiplying 2 powers that have the same base, you can add the exponents. So here I have 3 to the 5th times 3 squared. That means 3 times 3 times 3 times 3 times 3 times 3 times 3. So really, I just have 7 factors of 3 here. So I can write that as 3 to the 7th. And notice 5 plus 2 is 7. You can just add the exponents. Okay? All right. Thanks for watching.